Thank you. I'm very pleased to be able to be here today. We are the prime contractor for NASA on the International Space Station program, and as such, we have the opportunities to build a lot of exciting stuff and put it on orbit for the things that go on there. Next chart. How many of you know that we still have a space station up there? Have you heard and you know that there's a space station? Because a lot of people, when the space shuttle went away and when we stopped flying the space shuttle, they assumed that the space station was over also. And so the answer is no, we still are on orbit. This was a picture taken from the last, next to the last space shuttle that flew, STS-133, and that's what the space station looks like up there today, with the large solar arrays and the other things. There is going to be a handout that you guys will have available to you after this that'll have this photo on it, as well as the next chart. Next chart just has some interesting facts about the space station. It's pretty long, and you'll see that in a little bit. It weighs about 400 tons as assembled on orbit. No way we could launch that, and that's why it had to be assembled in space. Pretty great undertaking. It's about 200, a little over 200 miles above us, and traveling at 17,500 miles per hour. Have any of you ever seen it go over? We have one in the back, okay? So what I've done here at the bottom, and again, this will be available to you the next times that it should be good opportunities for viewing the space station will be on the 7th and 8th of April. And this is available on a NASA website if you want to see it. But if the weather is clear up here, this gives the time, shows the location from when it starts, and it'll come from low on the horizon, and on the 7th, it'll actually disappear as it gets up almost into the middle of the sky. And then the other one, you'll be able to see it go across and go down. The magnitude on here showing -3. The moon is a brightness of -1, so it's actually will be a dot that is higher intensity than even the moon at that point. And so these will be good viewing opportunities for you. Next chart. That's kind of what it looks like if you wanted to overlay it in Soldier Field or something. For those of you who may have been there or other football fields, that's about the entire size of the space station for you. This is an international space station. Here are the primary countries that are involved. A number of them have astronauts on orbit. We first launched the first piece back in 1998, and then in November of 2000 was when we put the first crew on orbit. And we've had crew up there from the United States for the past over 12 years now. And one of the things that we're doing is trying to make sure that we can continue to operate this, since it's been a large investment, and we're trying to extend the operation out through 2028. And so another 15 years of operation. And because of that, there's some things that we have to do because the space shuttle isn't there. One of the things that it used to do is every time the space shuttle went up, they would, before they left, they would empty their gas tanks with nitrogen and oxygen and fill up the space station tanks and then come back and return to Earth. And so that kept the tanks replenished up there. Well, now we have to do it with another method in order for us to continue to supply atmosphere and everything else, and that's where US Hose comes in. The next chart, this shows the space station when it was brand new. This is the US laboratory portion of the space station, and you can see it's nice and clean and everything's in there. So if you look at the next chart, we see that over time we store a bunch of stuff. because there's not a lot of extra closet spaces and whatever else, so it's getting kind of crowded up there, and doesn't look exactly like it was originally launched. But we've had a lot of visitors up there, and a lot of people over the last 12 years. So, why are flexible metal hoses so critical? I just mentioned that we're going to be taking up 6,000 PSI tanks that'll have our nitrogen and oxygen in them. And the only way to get this stuff out of there into the ISS systems is to have a flexible metal hose that can connect these tanks up to our systems. And that's where you guys come in, because you're building that flexible metal hose for the astronauts to be able to breathe, and as well as to do experiments, because the nitrogen, a lot of the nitrogen is used to conduct experiments on orbit, and so we need both of those for atmosphere as well as for the experimentation. Now, one of the things that doesn't seem obvious, and you know, we need this hose soon, because early next year we have to fly up additional gas to be able to keep the astronauts breathing. And so what do you think? What do you think we're going to fly up first? Nitrogen or oxygen? What's that? Well, the answer is nitrogen, okay? And so sometimes it's not obvious that, you know, I need to keep the astronauts breathing, and so I'm going to send up nitrogen. But our atmosphere is made up of 80% nitrogen, and we think about the oxygen because that's what our bodies use. But the first thing that we're actually going to fly up will be nitrogen tanks. The ISS does lose a little amount of air every day because, as I said, we assembled all these modules on orbit, so there's a little bit of leakage that goes out, as well as when they do EVAs or the spacewalks, they have to use the ultra pure oxygen that comes out of the tanks, and so the suits require that, and that's why we need also the extra pure oxygen that will be going up in these tanks. So one of NASA's top priority missions for early next year is to get the gas up there, and you're delivering your hose this year is going to help us do that. Next chart. So here's the system that'll be inside. This is the crew trainer, actually, that we have down in Houston. The black tank there is simulating the tank that these will go up in, and you can see the flexible metal hose that goes into the manifold assembly, and you can see all of the connections on the backside so that it can be routed to the different places in the space station once it's on orbit. Next chart. This is the airlock. This is the system that the area which used to take the gas from the space shuttle, and so it will be pulled out, and that assembly that you saw over there will actually go up into this location inside. And on the next chart, you'll see that we also will be installing these external to the space station, and so they'll be out on those big trusses. And down here in the corner, you can see astronaut Wirtz in the future there installing your hose, what it's going to look like when he installs the hose out during one of his spacewalks. So I know today we're excited, and I'm especially pleased to be able to tell you that Colonel Terry Wirtz was born in Baltimore, Maryland. He considers Columbia, Maryland to be his hometown. He's married with 2 children. He's a graduate of the U.S. Air Force Academy, the Embry-Riddle Aeronautical University, and Harvard Business School. He also attended the French Air Force Academy on an exchange program with the U.S. Air Force Academy. Selected as a pilot by NASA in July of 2000, Terry was a member of the International Space Station Expedition 9 crew and the Space Shuttle pilot aboard STS-130. He is currently training for his next space station mission as flight engineer on Expedition 42, scheduled for November of 2014, and continuing on as Commander of Expedition 43. Help me in welcoming Colonel Terry Virts.